Today we will look at an introduction to L'Hopital's rule, with our objectives being looking at the different types of indeterminate forms, looking at L'Hopital's rule, and finally finding limits using L'Hopital's rule. So there are two main types of indeterminate forms. A limit of the form limit as x approaches a of f of x over g of x, in which f of x goes to 0 and g of x goes to 0 as x approaches a, is called an indeterminate form of the type 0 over 0. Some examples of that you've probably already seen are something like the limit as x approaches 2 of x squared minus 4 over x minus 2, which the x minus 2 factors cancel, giving you just 4. Or the limit as x approaches 0 of sine x over x, which you've probably already seen to be 1. It's one of those special limits. And similarly, the limit as x approaches 0 of 1 minus cosine x over x, which is also 0. Similarly, a limit of the form, the limit as x approaches a of f of x over g of x, in which f of x is equal to infinity and g of x approaches infinity as x approaches a, is called an indeterminate form of the type 0, of the type infinity over infinity. Some examples of that are the limit as x approaches infinity of x over e to the x, which both go off to infinity, but for which the limit is 0, which we will show later, or even a more complicated limit, like the limit as x approaches 0 from the right of ln of x over cosecant of x, which gives you 0. Let's take a look at L'Hopital's rule. Suppose f and g are differentiable functions on an open interval containing x equals a, except possibly at x equals a, and that the limit as x approaches a of f of x over g of x is an indeterminate form of the type 0 over 0 or infinity over infinity. Then that limit is the same as the limit as x approaches a of the derivative of f over the derivative of g, if that limit exists. Essentially, L'Hopital's rule says if you have an indeterminate form, then you can just merely differentiate the numerator and differentiate the denominator separately, and that ratio will, the limit of the ratio will be the same. Let's see how this works to find a limit for which we already know is 4, and we already have another technique to use. So as you can clearly see, if you plug in x to be 2 in the numerator, you get a 0, and if you plug in x to be 2 in the denominator, you also get a 0. So this is an indeterminate form of the form 0 over 0. So if we apply L'Hopital's rule, it says that this limit should be the same as if we differentiate the numerator, x squared minus 4, over the derivative of the denominator, x minus 2. Both of these are pretty easy limits to differentiate. Pretty easy derivatives to differentiate. The derivative of x squared minus 4 is just 2x, and the derivative of x minus 2 is just 1. That's a polynomial, so we can just evaluate it to determine the limit, which gives us 4. Similarly, for example 2, let's find the limit of sine x over x as x approaches 0, which we already know is 1, but if you plug in x to be 0, sine of 0 is 0, and x evaluated at 0 is 0, so that's also in the indeterminate form 0 over 0. And L'Hopital's rule applies, and it says that the limit as x approaches 0 should be the same as the limit of the derivative of the numerator, so the derivative of sine of x, all over the derivative of the denominator, which is x. So that's the same as the limit as x approaches 0 of the derivative of sine is just cosine. And just like before, we could see that the derivative of x is just 1. And now we can just evaluate cosine at 0 since it's a continuous function. And cosine of 0 is 1. And there's a value which we already know. You could see in general what L'Hopital's rule does for you through differentiation is it simplifies the expression for which you're trying to take the limit of. Last but not least is our third example. Find the limit as x approaches infinity of x over e to the x. Now this is of the indeterminate form infinity over infinity, since both x and e to the x have a limit of infinity as x goes off to infinity. So in order to compute this limit, we'll again apply L'Hopital's rule, which says that this should be the same as the limit as x goes to infinity of the derivative of the numerator, so derivative of x, all over the derivative of the denominator, so the derivative of e to the x, which is the limit as x approaches infinity of the derivative of x is 1, derivative of e to the x is e to the x, which is its own derivative, which is the same as the limit as x approaches infinity of e to the 1 over e to the x is e to the negative x, and that's an exponential decay function which goes off to 0 as x approaches infinity. Once again, we got a simpler expression to try and compute the limit of after applying L'Hopital's rule. So those are three basic examples in which we use L'Hopital's rule to compute a limit, and that concludes our video of an introduction to L'Hopital's rule. Hope you have a great rest of your day.